ലൈൻ ഇൻറ്റഗ്രലിൽ കുറച്ചും കൂടെ പ്രോബ്ലംസ് നമുക്ക് ചെയ്യാം. ഇതിൽ ഇപ്പോൾ ലൈൻ ഇൻറ്റഗ്രൽ എന്ന് പറയുമ്പോൾ എല്ലാം ക്ലോസ്ഡ് കർവ് ആണ് നമ്മൾ ചെയ്യുന്നത്. ക്ലോസ് കർവിൽ നമ്മൾ രണ്ട് തിയറംസ് ആണ് കണ്ടത്. ഒന്ന് കോഷ്യസ് ഇൻറ്റഗ്രൽ തിയറം, കോഷ്യസ് ഇൻറ്റഗ്രൽ ഫോർമുല. ഈ രണ്ടും വെച്ചിട്ടുള്ള കുറച്ച് എക്സാമ്പിൾസ് ആണ് നമ്മൾ ചെയ്യാൻ പോകുന്നത്. സോ ഇവാലുവേറ്റ് integral over c 2z square plus 5 divided by z plus 2 the whole cube into z square plus 4 dz, where c is the square with vertices. The vertices are given to be 1 plus I, 2 plus I, 2 plus 2I, 1 plus 2I. So C is the boundary of the square with these points as vertices. So 1 plus I means 1, 1. Then 2 plus I, so 2, 1. Then 2 plus 2I, 2, 2. And 1, 2. So the boundary of this square is C. It's a closed curve and this curve is C. So the boundaries are 1 plus I, 2 plus I, 2 plus 2I, 1 plus 2I. Now look at this function. The points where this function is not analytic are z equal to minus 2 and z equal to z square plus 4 equal to 0. That implies z square equal to minus 4, and which gives set the value plus or minus 2i. So the points where the function is not analytical, z is equal to minus 2. Obviously z equal to minus 2 is outside the curve C, and z equal to plus or minus 2i. So plus 2i and minus 2i both lies on the vertical axis. This is 2i, this is minus 2i. So all these points, the integrand is not analytic at these points, and all these points lies outside C. Right? So you can conclude that the function is analytic within C. And C is a simple closed curve. So as the function is analytic within C, by Cauchy's integral theorem, we can write the integral over C fz dz equal to 0. So the function is quite a big function. We just locate the points where the function is not analytic. We draw the contour C. As the points where the function is not analytic is outside this contour, you can conclude that integral over C fz dz is equal to 0. Now the next example, integral over C tan z dz, where C is the circle mod z equal to 1. So C is the circle mod z equal to 1. You draw it properly. Mod z equal to 1, and this function, we know tan z is equal to sin z by cos z. Both sin z and cos z are analytic functions. So tan z will be analytic at all points except where cos z equal to 0. So cos z equal to 0 implies z is equal to plus or minus 2n plus 1 pi by 2. Right? The points are plus or minus pi by 2, plus or minus 3 pi by 2, etc. Now, we know the value of pi is 3.14. So, the absolute value of pi by 2 is greater than 1. Like 3.14 divided by 2, 1. So, pi by 2 minus pi by 2, 3 pi by 2 minus 3 pi by 2 all has its value more than 1, and for the circle the radius is 1. So, all these points will lie outside the contour. Minus pi by 2, 3 pi by 2, etc. So, we can conclude that all these points lies outside C. Therefore, tangent is not an entire function but within this contour. Tangent is analytic within C. So don't ever think that integral of tangent will be always equal to 0. If you take the contour as mod z equal to 1, it contains no singular point of tangent. Hence, you can say that tangent is analytic within C. Hence, integral over C tangent dz equal to 0. Things will change if you expand the circle. Once it encircles the boundary, the points where the function is not analytic, then the integral may not be equal to 0. So, for mod z equal to 1, it contains no singular points. Hence, we can say the integral is equal to 0. Another example. Integral over C e raised to z divided by z square plus 9 dz, where C is mod z equal to 2. So C is a circle with center 0 and radius 2. And again, the numerator e raised to z is analytic. Z square plus 9 is also analytic. So we look for the points where z square plus 9 equal to 0. So this implies z is equal to z square equal to minus 9, or z is equal to plus or minus 3i. Right? So again, 3i and minus 3i, their absolute value mod z is 3. So 3i and minus 3i will lie outside mod z equal to 2. Right? So we can conclude that this integral is equal to 0. Now consider integral over C sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where C is mod z equal to 3. So we can say it is not analytic, the integrand is not analytic at z equal to 1 and z equal to 2. So if you look at this contour, we have mod z equal to 3 and z is equal to 1 and z is equal to 2 are the points where the function is analytic, and both these points lies inside C. So you cannot apply Cauchy's integral theorem. The function is not analytic within C. So we try to apply Cauchy's integral formula here, but the problem here is we have more than one factor in the denominator, more than one linear factor in the denominator. So we try to split this. So 1 by z minus 1 into z minus 2, and these are consecutive integers. You can easily write the partial fraction. You write the bigger term first, 1 by z minus 2. Z is not in the numerator, so 1 by z minus 1. So just see and separate, see what the numerator is. So you can see while subtracting, the numerator happens to be 1. So to get this integral f of z dz, you just multiply with the numerator. So we get integral over c sine pi z square plus cos pi z square divided by z minus 2 minus sine pi z square integral over c sine pi z square plus cos pi z square divided by z minus 1. Okay, so see, the numerator consists of sine and cosine functions. They are analytic. Now this takes the form integral over c fz by z minus a dz, and the value was 2 pi I into f of a. Okay, so we get, in the first case, in the first integral, the value of a is 2. In the second integral, the value of a is 1. So we can write this integral as 2 pi I into sine pi z square plus cos pi z square evaluated at z equal to 2 minus 2 pi I into sine pi z square plus cos pi z square evaluated at z equal to 1. So we get 2 pi I into, when z is 2, we get sine 4 pi. Sine 4 pi is 0, cos 4 pi is 1. So 2 pi I into 1 minus 2 pi I into, when z is 1, we get sine pi, which is 0, cos pi is minus 1. So we get the answer as 4 pi I. Next example, integral 4 minus 3z divided by z into z minus 1 into z minus 2 dz, where c is mod z equal to 3 by 2. So points where the function is not analytic are z equal to 0, z equal to 1, z equal to 2. So for z equal to 0, mod z is less than 3 by 2. For z equal to 1, mod z is less than 3 by 2. So they lie inside C, and z equal to 2 lies outside C. So z equal to 0 and z equal to 1 is within C. So we bother about only those points. Mod z equal to 3 by 2 ന്റെ ഉള്ളിൽ 2 പോയിന്റ്സേ ഉള്ളൂ, സെറ്റ് 0 ആൻഡ് 1, ആൻഡ് 2 ഇതിൻ്റെ പുറത്താണ്. അപ്പോൾ നമുക്ക് പറയാവുന്നത് ഈ 2 വരുന്ന പാർട്ട്, ഇത്രയും പാർട്ട് അനലിറ്റിക് ആണ് വിത്തിൻ സി. സോ f of z equal to 4 minus 3z divided by z minus 2 is analytic within C. So you can write this as fz by z into z minus 1 integral over C fz by z into z minus 1 dz. And to separate the denominator, 1 by z into z minus 1 can be written as 1 by z minus 1 minus 1 by z. So we get this integral as integral over C fz by z minus 1 dz minus integral over C fz by z dz, which is equal to 2 pi I into f of 1 minus 2 pi I into f of 0. So which we get as 2 pi I into f of 1 is, f of z is 4 minus 3z divided by z minus 2. So f of 1 will be equal to 4 by minus 1, which is equal to, 4 minus 3, 1 by minus 1, which is minus 1. F of 0 will be equal to minus 2. So we can write f of 1 is minus 1 minus 2 pi I into minus 2, which we get as 4 pi I minus 2 pi I, which is equal to 2 pi. So like this you can separate the denominator and find the integral.